Hello students, today we will see the concept of big data processing under the subject data science and big data analytics. Now for the big data processing we have a cycle which differs from transactional data cycle. In the traditional environment we first analyze the data, create a set of requirements which leads to data discovery and data model creation, and then a database structure is created to process the data. So this is our traditional way to work with the transactional data, but the data processing, which is a big data processing, is different from this. The resulting architecture is very efficient from the perspective of write performance, as the data's finite shape, structure, and the state are loaded in the end state. So if you see this particular big data processing cycle, we have basically 5 stages in the cycle. First, we have to collect the data, then we discover the data, process the data, manage the data, and generate the data. So here in the collection stage, we have to capture the transaction data, collect the data from the subsystem, and data collection from the forms in the portals is done. In the step of discover, the discovery with respect to classification, categorization, tagging, model building, all the discovery models is done. In the stage of processing, the data is transformed, it is sort, merge, calculation, summarization, every kind of processing is done in the stage of processing. In the stage of managing, we have the storage, retrieval, archival, governance, all these management activities done on the big data. And at the last, for generation stage, we have the advanced computation, formatting, and presentation. All these operations can be done in the data processing cycle. Now, this big data processing cycle widely differs for the perspective of processing. Data is first collected and loaded to a target platform. Then the metadata layer is applied to the data and the data structure from the content is created. Once the data structure is applied, the data is transformed and analyzed. And the end result from the process is what provides insights into the data and any associated context based on the rules. To process the data in this flexible manner, a database driven architecture will be unsuitable and will underperform. So we cannot directly use a database based architectures for the purpose of big data, and to process this volume and the complexity of file driven architecture with a programming language interface is best suited. So a big data can be saved in the file instead of just database solutions or database management systems. So based on this conclusion, what we say is the key requirements for infrastructure and processing architecture are given as next. So the data processing architecture requirements for big data, we have data model-less architecture. No need to have a specific model for this. Then near real-time data collection. Actually, we have to collect the data real-time basis, sensor data, then various location data, and so on. Then micro batch processing, we have to process the data in some batch fashion, in some sequence fashion, not all together. Minimal data transformation, that is another requirement where we should have less amount of data transformation, what we have the data which is to be converted, processed, and transformed with the minimum set of processing. Then efficient data reads, we have to do the efficient data reads from the storage. Then multi-partition capability, where we should store the data in multiple ways. Horizontal partition, vertical partition should be allowed for this data. And the store the result in the file system or DBMS, not relational. So we generally store the databases which are not relational, and we prefer to store the data in the file system. Like Hadoop file system that we will see, and share data across the multiple processing points. It is possible to work at the various processing levels, various processing stages. So we should store it at the various processing points. Then, considering the infrastructure requirements, we should have linear scalability, high throughput, fault tolerance, auto recovery, high degree of parallelism, distributed data processing, and programming language interface. So, as we see, we have a massive amount of data, we have big data, we should have a scalability with respect to this infrastructure, we should get the high throughput with the infrastructure, then fault tolerance, an important aspect as we have for any kind of distributed system, then auto recovery, where we should recover from the various problems or the faults which may occur, then high degree of parallelism, where we should allow this massive data to work parallelly as it is very the high degree, high voluminous data. And the distributed data processing, as we have seen in the previous requirement, we have to work on the distributed data processing and with the programming language interface like HBase, Hive. The key element that is not required for big data is the need for relational database that we have seen provide a backend platform for data processing. And interestingly, the architecture and infrastructure requirements for big data processing are closely aligned to web application architecture. Furthermore, there are several data processing techniques on file-based architectures, including operating systems that have matured over last 30 years. So every data we are storing in the file system that is more preferable to work on to get efficient data processing environment in the distributed data processing over the big data. Combining all these techniques, a highly scalable perform platform can be designed and deployed. And to design efficient infrastructure and processing architecture, we need to understand data flow for processing big data. So how it is done, which we'll see in the next figure on the next slide. So there are four distinct stages of processing and each stage requirements for infrastructure remains the same. So which are the four stages for big data processing? We have the landing zone, we have the ingestion zone, processing zone, and the discover. So first we landing zone, we are putting the data in this raw data, we are gathering the data. Then we are putting in the ingestion phase where we are loading the data. Then processing is done in the processing phase and the discovery with respect to this is done in this discovery phase with respect to analytics, database integration, operational reporting, raw data extraction, all kind of discovery. So here basically gathering the data, loading the data, transforming the data, these are the key stages for the big data processing as shown in the figure. So here the gathering of data is received from different sources, loaded to a file system as we see called landing zone or landing area, and typically data is stored into subdirectories based on the data type. Then loading the data, the loading data breaks down the large input to small chunks of data. As we have very large files, we should store it in the small chunks, small sizes of files. And the catalog of the files is created and the associated metadata for the catalog is processed for that file. So we have to maintain the metadata, not only just chunks of files or the splits of the files. Then the next stage, as we see, the transformation of the data. The data is transformed by applying business rules and processing the contents. This stage has multiple steps to execute and quickly become complex to manage. So multiple steps are there in the transformation. Various transformation operations can be performed on the data as per the requirement, as per the application and the business logic that we want to apply next. Then the fourth stage is extraction of the data. In this stage, the result data set can be extracted for further processing, including analytics, operational reporting, data warehouse integration, and visualization purposes. So what is the application we want to do from this big data that we are going to apply as the extraction of data? So whatever is the required output that can be done with the various kinds of operations like analytics, reporting, integration, visualization, and so on. So here we can summarize the big data processing as a file-based system, scalable distributed data processing architecture, designed and deployed on the high performance and scalable infrastructure. Then big data architecture is not a fixed one size fits all architecture. We have to do as per the size, as per the requirement, as per the need of the application. So as seen in figure, each processing layer within the architecture has at least several solutions and techniques that can be implemented to create a robust environment. So we'll see the figure next where we see various environments and various tools available to work on that particular stage. Now in the landing zone, we can see that we can implement this or we can use the Unix file system, Amazon S3, HDFS, any kind of file system over here. In the ingestion, we can use the data like system like to Hadoop HDFS, NoSQL, and Google file system, Amazon EMR, and various solutions available for ingestion purpose, where we are splitting the data, where we are putting the data at various locations, various systems. Then we have the processing of this in this MapReduce can be used as a framework which is important for doing this various summarization purposes. The HiQL, the query language which can be implemented as a processing part, then Python, Ruby, Java, all these programming languages can be also used for the processing purpose to get some application, to implement some application over here. Then at the last we have the discovery where we can use the data mirror, quest software, chemasphere, quick view and many more. For the purpose of discovery, as per the application, we say analytics can be implemented, database integration, the operational reporting, raw data extraction, all these types of operations can be done after discovery. So here for analytics purpose, we can use R programming, Mahout, then SAS programming. For database integration purpose, we can use the Scoop, JDBC, native drivers, and so on. For the operational reporting purpose, we have the BI tools on Hive, then Tableau is there, Spotfire is there, QuickView is there. The raw data extracts were the custom scopes and tools. So looking at this overall structure and architecture of big data processing platforms, we see that there are a variety of softwares and various tools available to work on every stage of this big data processing. So this is all about the big data processing. Thank you.